Okay, so we fire it from here, right? And we know, so it starts off right here with a velocity of 1,000 meters per second, right? Okay, and we know, by the way, that when it's 266 kilometers above the surface, that it's going 500 meters per second, right? And furthermore, we know that it goes a bit farther than that, right? So here they're saying when this distance here is 300 kilometers, right? How fast is it going? So this thing, what's its velocity when it's 300 kilometers above the surface? What is that v here? If it's going 1,000 at the surface, what is its velocity 300 kilometers above the surface, right? So what we got to do is figure out the r, right? The new r is going to be 300 times 10 to the third. That's 300 kilometers, right? Plus 1.737 times 10 to the sixth, because that's the radius of the moon. So this is the distance from the center, which is what we have to use in our equation. So let's figure that out. So 300 E3 plus 1.737 E6 is 2.037 times 10 to the sixth meters from the center is where we are, right? Right, and then we want to figure out its velocity, right? So we're going to say that this potential energy here, which is minus g, the mass of the moon, mass of the bullet, over the radius of the moon, right? That'll be the radius of the moon, plus its kinetic energy, and this will be the mass of the bullet as well, times v squared. And this v is going to be 1,000, right? That equals minus g, mass of the moon, mass of the bullet, over the new r, which is going to be this guy, plus 1/2 mass of the bullet, right? That's also mass of the bullet, times the new velocity squared, right? So that new velocity is what we're solving for, okay? Notice that the mass of the bullet goes the way of the bison here. Actually, the bison are doing fairly well, so I should stop saying that. All right. And let's just plug our numbers in here, right? Let's see. So minus g times 7.35 times 10 to the 22nd divided by, and it starts on the surface, so it's 1.737 times 10 to the sixth from the center, right? And it's moving 1/2, and then we've already crossed off the m, so it's 1/2 1,000 squared, right? That's going to equal minus g times 7.35 E22, that's times 10 to the 22nd, right? Divided by this guy, right? 2.037 E6 plus 1/2. I guess this is what we're solving for, right? So what is the velocity, right? E prime, we're solving for that guy. Okay. All right, what do we do? I guess what I'm going to do is I'm going to figure out this whole side here. I'm going to add this term to it, and then I'm almost there, right? So figure out this side. I'm going to add this term to it because it's a negative term, right? And then I'll get this velocity. Okay. So the opposite of 6.67, E minus 11 times 7.35, E22 divided by 1.737, E6 plus 0.5 times 1,000 squared. And this side, this thing here is minus 2322366.149. Let's figure out this term right here. All right, hold on. 2.037 E6 All right, here we go. Do I have the right thing? All right, I think I got it. This is -2406701. Let's see, 1. Okay. So now I'm going to go this guy. I'm going to add that guy. So make it positive. And I've got 84334.882 is 1/2 v squared. So now I'm going to multiply that by 2, take the square root. 410, so v is 410.69 meters per second, so about 411 meters per second. All right. Woohoo!